What's up, guys? Today's lesson is about square root functions. We've been talking about inverses the past few days. Well, check it out. We're graphing the square root dude and just see what he looks like. Remember the square root and like the parabola, like f of x equals x squared, like squaring and square rooting are inverses of each other. So, like if you had a plain Jane parabola right here, it would look like this. And we learned that inverses reflect to each other over the line y equals x. You can see that we don't get the whole parabola though this time because it's supposed to be Mr. Sideways tree right here. It doesn't quite work because the domain is all messed up for square root guys. The domain, remember, you can take the square root of a positive, you can take the square root of 0, but you can't take the square root of a negative in the real number system. So that's why this guy's domain goes from 0 to infinity, right? And 0 is included as you work from left to right, and his range, if you go low to high, is from 0 to infinity also. This is just the parent square root function, though. So what we're going to do is do a little purple note card. If you want to get yours out, you can. But it's just a refresher so we can kind of understand what the square root function looks like a little bit. And, truthfully, I don't want to do the whole 4 steps to the purple note card. I think the first 3 steps are good enough. So let's do a little step 1, 2, 3. And remember, the questions ask us if it gets reflected over the x-axis, translated, dilated, all that good stuff. But let's go back and check out our generic function again that we have for our transformations. We had these parentheses that we always saw. Well, those are just generic grouping symbols. Now, the grouping symbol that we got is actually this square root right here. So he is the grouping symbol, like where the parentheses are. So we just kind of got to realize that. And if they ask us if this guy gets reflected over the x-axis, remember we look at that a value, which is the number in front of the parentheses or in front of the group. Well, that's now the number in front of the radical. If he's negative, then this guy gets reflected over the x-axis. Well, he's not, so it doesn't happen. Then the translation, we were really good at that. Translate, like h comma k. Remember, you got to do the opposite of this because he's in the group, right? And he's got a minus in front of it. And then what you see is what you get right here. So if we look at this plus 4, he's in the group because he's underneath that radical symbol, right? He's inside there. So this plus 4 is actually a little opposite game, meaning he gets translated 4 units left, and then up or down, nothing happens here because they didn't add a number off to the side. And then the dilation, we're just going to try to make it as simple and easy as possible. The dilation happens about your a value and your b value. Those are these numbers, the number in front of the group and the number in front of x here. If they're 1, you're going to stay the same size. You're not going to vertically stretch, vertically compress, or any of that. So rarely this will happen, but it will happen. We'll do some here shortly where it does happen. So they want us to make a sketch of this. Well, again, since it's our first go-around, don't sketch this, but this is the plain Jane square root function. Looks like this. Okay, what we are doing is moving it. It has been translated 4 units to the left. That is the only thing that has happened to this guy. So the endpoint normally starts at like 0, 0. This thing's got to go 4 units left. But let's kind of talk ourselves through it. Like, it didn't get reflected over the x-axis, but I'm going to show you what happens if it did. If it did get reflected over the x-axis, it would look like this green guy right here. And as lame as this is going to sound, I kind of call this like a T-Rex's mouth right here. Like if you had some cool teeth and roar. I'm such an idiot, but still, it's like a T-Rex's mouth. The red part is like the top of the T-Rex's mouth, and the bottom part is like the green part is the bottom of the T-Rex's mouth. So that'll make sense later when we need it. But the square root function, he kind of looks like the top of the T-Rex's mouth in this deal. So that means this guy's been translated 4 units left. This is the graph you need. We're going to go minus 4, comma 0. And he's this normal size, nothing crazy has happened. So you don't need this dude, we just have him, right? The normal parent guy's been translated 4 units left. Let's do domain from left to right. It starts at -4, and it is included. And then that thing's going to keep going to the right forever and ever and ever. Range will go low to high, not touching, not touching, not touching there. It starts touching at 0. And he's included, and this thing will get higher and higher and higher as it goes, so it'll go to infinity. So a little trip down memory lane. Sorry, I went too fast. Let's go to number 2 here. Let's do a little step 1, 2, 3 for the purple note card. Has he been reflected over the x-axis? Nope. Translated, since this dude is under the radical, like he's in the group, we do a little opposite. Up or down, nothing happened. And has it been dilated? Well, this is a 1 and this is a 1, so no dice. All we do is move the point 003 units to the right. And it didn't need to go up or down. You do need to put this ordered pair here, though. So, and because it hasn't been reflected over the x-axis, he's a normal guy. It's like the top of the T-Rex's mouth. So domain, it goes from left, nothing, 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 bing, from 3 included to infinity, and the range, low to high, nothing, 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 bing, started at 0, and it's going to go up to positive infinity in that case. So, cool. Why don't you give this one a shot? Get step 1, 2, and 3 done, and just kind of check with mine real quick. So here's my steps. It does not get reflected over the x-axis because this is not negative. Translated 2 units right, a little opposite game, and 5 units up, because what you see is what you get there. Since these were 1s, no dilation. So then the point 0, moves 2 units right, 5 units up, and we need the top of the T-Rex's mouth because this thing has not been reflected over the x-axis. So like so. Domain, starts from 2 and goes to infinity as you work from left to right. Starts at 2, and range, go low to high. Low is 5. That's the lowest this thing ever gets, and it's going to go up to infinity. So one more. Step 1, has this guy been reflected over the x-axis? You bet. So that's going to be the bottom of the T-Rex's mouth. Translated, -6, -2. And dilated it all, even though it's not like 1, it's the absolute value of these guys, remember? So he's a 1, he's a 1, it doesn't happen. So we'll still go move 0, 0 first, -6, -2. But because he got reflected over the x-axis, we need the bottom of the T-Rex's mouth like so. So as lame as that T-Rex thing is, it really helps if you get reflected over the x-axis. The square root dude flips over, looks like so. Let's do domain from left. It starts touching at -6 included, and then this will just keep on keeping on to infinity. The range, though, is going to be a little different because as low as we go, well, this thing's going to keep getting lower and lower and lower and lower. It would touch the straight edge way down here at -infinity. And then as we go higher and higher and higher, this is the highest it gets, which is -2. So we had this switch around on us compared to the normal ones because this thing got flipped over in that case. So neato burrito. So that's just knowing what the graphs look like. Now they ask us the same story that we did last class period about if the inverse is a function and etc. So we could punch this in our calculator to see what the graph looks like, or we have the knowledge now to know what this guy's going to look. So I'm going to ask you to put the 3 steps for your purple note card. This guy has not been reflected over the x-axis. He has been translated 1 unit left and 0 units up, and 1 and a 1, so everybody's the same size. It hasn't been vertically stretched or any of that good stuff. Let's make a little sketch of this guy. He has been shifted 1 unit left, so newt, and we got the top of the T-Rex's mouth, so bada boom. This will allow us to answer this. Is the inverse a function? Well, that's what we did last time. We used the horizontal line test, and yes, this graph passes the horizontal line test. So if you need to pause to write that down, go ahead, but I'm going to just keep on talking. Then they say, if we say yes, we got to answer these questions. So domain and range of this guy, -infinity. Whoops, my bad. We got to go from -1 included. Sorry, to infinity. Right, because that's what. Sorry, pen drag. That's where that thing starts from. And the range, we go low to high. From 0 is how low she goes, all the way up to infinity. So cool with that. Part C was do the 4-step process. So nice. We'll change that to a Y. And step 2 is switching X and Y around. That's the true inverse step. And then the question is, what should we do next? Should we get rid of the square root or should we get rid of the plus 1? Well, if you're ever in a group, like some sort of crazy group, we can't really see what's in you. So like this is all underneath the radical. We've got to get rid of the radical first before we can start subtracting the 1. So to get rid of the square root, we're going to square both sides. So we'll do that. And this will become x squared. And this guy right here, the square root is going to go away, is y plus 1. And now we can subtract the 1 over. So get x squared minus 1 equals y in that case. So that's step 3. Step 4 is, let's just go put that in a blank, is to change y to f inverse of x. And I got x squared minus 1. And for domain and range, that's where we pull the switch, because this is an inverse and we switched x and y around. The domain of this guy is 0 to infinity, included on the 0, and the range is this. And what I'd like to do just on this very first one is show you that, right? So you can just kind of watch. You don't need to do anything, but I got this on Desmos right here to where this was the problem that we just did. We totally just did f of x equals the square root of x plus 1. We wanted its inverse. So last time we literally just type x equals f of y in for this guy, and it graphed the inverse of that dude, and check that dude out. That totally makes that, that reflects to each other over the line y equals x. But what we can do also to double check that is, because we didn't do any work, we could type what we got for part C here. It's we could type we could type this equation in to Desmos to see if it's going to graph what we want. Because what we should get is our graph should be right on top of this, because we know this is the inverse. So can't do f inverse, so I'll just do y equals, it was x squared minus 1. Minus 1. And the problem is, it didn't match up. It's this is totally a parabola, and it didn't match up. And the reason why it doesn't match up is because the domain doesn't allow for all real numbers in this case. The domain needs to be from 0 to infinity. So that's why we have to restrict the domain. And you can type that in like this into Desmos. You put the cool little bracket like this, and you just say, well, the x's had to be greater than or equal to 0, because that is exactly what we said in part D right here, that the x's had to be greater than or equal to 0, from 0 included bigger. So just kind of show you that a square root and a parabola are the inverses of each other, but you can't have the entire parabola. You have to restrict. Let me change the color of this guy. Let me make him a green guy. So here's the green dude. That's what we wrote. If I make him go away, he should be right on top of that red dude. The red dude and the green dude are exactly the same thing. They are the inverses of each other. So just showing you that the restrictions in the domain matter in that case. So let's do the rest, just kind of quick and easy. First, we'll make a 1, 2, 3. This guy has not been reflected over the x-axis. He has been translated 4 units to the right, because that's inside the group, and 0 units up, and no dilations whatsoever. We'll make a sketchy McSketcherton of this guy. Translated 4 units right. Please put the ordered pair. And beep. Top of the T-Rex's mouth, just a normal square root guy. Is the inverse a function? Well, that dude passed the horizontal line test, so I'm going to say yes. And again, if you need to pause to write that down, go ahead, because I already got it pre-made. Domain of the OG, going from left to right, it's about 4, included to infinity. In the range, we go low to high. A lot of people have been asking me questions on the range. Remember, it starts at 0. It'll go low to high, and then this thing's going to keep on keeping on. So from 0, the y value, to infinity. Let's write the equation of the inverse. Step 1. Meow. Step 2. Switch. And since this stuff is under the radical, right, we're going to get rid of the radical first by squaring both sides. So x squared. Oops, I'm squaring both sides, so the radical's gone. There we go. And now you can add 4 to both sides. If I could. Sorry, I'm having trouble writing today. There we go. And then step 4, f inverse of x equals x squared plus 4. The domain of that guy is now the original range, switchy switchy, and the range of this guy is the original domain. And I just want to show you now on paper, it's like, let's see if this makes sense. Like if I just had you look at this all by itself, would you know that this has to be a parabola, right? And it's been shifted 4 units up since we're doing the purple note card. Well, check this out. Look at this ordered pair, the endpoint of this guy. We want the inverse. What would be the inverse of 4, 0? Isn't it 0, 4? That's this thing right here, 0, 4. You don't need to draw this, but still. And then we don't want the whole parabola. We just need half of a parabola in this case. So one of these parts is right, and one of these is wrong. Which one do you think looks like it reflects to this original guy over the line y equals x? It's the blue one, the one where we were positive in that case. So this isn't really here, and that's what the inverse of this guy looks like. But the domain can only be 0 or bigger, because this guy only allowed 0 or bigger to his party. So let's try that again. This one's weird, right? If you've stopped by now, shame on you. This one is really weird because we kind of lied to you at the first semester about the b value here. This b value, we didn't quite do it right for a reason, because we didn't think you could handle doing it right the very first time. It was just a little too confusing, but now we're going to do it right. Here's what happens when you have a number in front of x inside the group. That b value, you must factor him out. Even if there is no GCF or anything, you must factor out whatever that number is. So since it's a 2, we are going to factor that 2 out of this. And it's like reverse distributive property. Wouldn't you get x minus 2 back? Just check. If you did distribute this 2 through, you should get this back. This is how we have to read this for purple note card to see what happens. So that's new, but we didn't want to show you that way back in the day because it was just too much. Right? So let's purple note card this guy. Has he been reflected over the x-axis? No. Translated. Now this is why we needed to do that, because this dude has been translated just 2 units right. That's what we got to look at. Translated 2 units right, 0 units up. Most people would have thought it was translated 4 units right, and I get that, but just you got to factor that guy out. And then boom, boom, this has been horizontally, and since it's compressed, you can use your purple note card because that b value is bigger than 1 times 2 in that case. So let's go making a sketch of this guy. He's got a endpoint at 2, 0, because he's been shifted 2 units right. And vertically compressed, if you use your hand, it makes you a little fatter. So that's going to make this guy a little taller McTollerton. Truthfully, we don't care about you making this the right kind of dilation, if it gets stretched or compressed. We care about you just make the sketch right, and that he's the top of the T-Rex's mouth. And put the 2, 0 in the right place instead of a 4, 0. Is the inverse a function? Oh yeah, because the graph passed the horizontal line test. So let's do the domain. Reading from left to right. 2 included to infinity, and the range 0 to infinity. 4-step process. You could do it on either one of these. It really doesn't matter. It's probably a little easier for us to do it on the orig. It doesn't matter. It'll all work out the same. So let's do it on the orig. Change this to a y. Switch. And then here, all this stuff is under the radical. So we will square both sides. Square the square root canceled. And now we want to add 4. We still have to divide by 2. So y will equal, I'm going to divide every term by 2, x squared over 2 plus 2. You could also call that like 1/2 x squared, but it's all the same thing. If you put x squared plus 4 all over 2, I'll accept that. Don't know if Trey or Dinahan will, but you ask them. But whatever they want, you put f inverse of x equals that 1/2 x squared plus 2 in that case. And then the domain and range, switch them. You could go to Desmos Calculator if you want to. All you got to do is Google Desmos Calculator and it'll pop up for you. It's a free calculator. If you want to, you type the original guy and then you type this dude in and you type x equals f of y, and you just got to restrict your domain on that other one. But that's up to you if you want to or not. Hey, why don't you try this guy all by yourself? Make a little sketch, do the purple note card thing first, and then pause the video and check back with mine. I got him up to step 2 of the 4-step process. Just wanted to show you that step 3 solve for y. We want to get rid of this plus 3 first because he's not under the radical. So we'll do a little x minus 3 equals the square root of y. Right? Now we square both sides. And remember, we want to do the whole side. So just quantify this. Squared equals y. And then we got f inverse of x equals x minus 3 quantity squared. Don't worry about like expanding that out. Like, I want to see it like this personally because I can tell that this parabola has been shifted 3 units right, just like this should be at 3, 0, and then the switchy tells me what its domain is on that case. So pretty neat. Hey, just one more, I think. Maybe that was the last one. Nope, one more. So we'll do the 3 steps. So no reflection, translated 3 units left and 4 units down, right? No switchy on that, and no dilation. And we'll graph him. 3 units left, 4 units down, doodaloo. And he's the top of the T-Rex's mouth. And he's definitely a function. The inverse is definitely a function, I should say, because the graph passes the horizontal line test. So 3 in the domain, -3 included to infinity, -4 included to infinity for the range. Switch around for step 2. Y plus 3 minus 4. Got to get rid of the minus 4 first, so I'll add 4. Now I can get rid of the square because I got the radical all by itself, so I need this to be in a group squared, and I'll get y plus 3. Again, if you need to see what's going on here, it's like I'm going to square this side, and I'm going to square this side, and those cancel, you know. And then I'm going to get y by itself by subtracting 3, and you can't do it to the 4 because it's in the group getting squared, so it's just a little -3 equals y. So f inverse of x equals x plus 4 quantity squared -3. And you can see that that would be a parabola that's got a vertex at -4, -3, the inverse of this. But it's not all reals for that parabola's domain. It is the switchy mixed switch. So pretty basic. Let us know if you have some questions. There is a couple tough ones on the homework, you know, but most of them are in this ballpark. Let us know if you have any questions. Have a good one.